Hey everyone, and welcome. Today we're diving deep into something that's fascinated us for, well, forever, time travel. But we're not talking about Hollywood movies here. We're going to strip away all the fiction and look at the real, hard physics to see what's actually possible versus what's just a great story. Let's get into it. So, let's just cut right to the chase, shall we? Is time travel possible? The answer, incredibly, is yes and also no. And trust me, the why behind that answer is way stranger and more mind-bending than any sci-fi movie, because it forces us to completely rethink what time even is. You know, when you think about time travel, you probably picture the stuff on the left. DeLoreans, grandfather paradoxes, just hopping around the timeline whenever you want. But yeah, we're going to leave all that stuff behind for today. We are focused squarely on the column on the right, the real physics of relativity, spacetime, causality, and the fundamental rules that our universe actually plays by. Okay, so before we can even begin to talk about traveling through time, we got to ask a much bigger question. What even is time? Because it turns out it's not that constant universal clock ticking away that we all imagine it to be. And that's all thanks to one guy, really, Albert Einstein. He completely blew up our old ideas about time. What Einstein showed us is that space and time aren't separate things. Nope, they're woven together into this single, four-dimensional fabric called spacetime. And here is the absolutely wild part. That fabric isn't rigid. It can be bent, stretched, and warped. The speeds you're moving at or the strength of gravity around you can literally change how fast time flows for you compared to someone else. And get this isn't just a theory. It's a proven, measurable fact of our universe. So this leads us to something pretty stunning. Seriously, here's the big secret of this whole explainer. Traveling into the future isn't science fiction. It's not a hypothetical idea. It is a scientifically confirmed, 100% real feature of our universe. So how does this work? Well, it's all because of a phenomenon called time dilation. It's a fancy term that just means time can and does run at different rates for different people. And there are two main engines that make this happen, both predicted by Einstein and, you guessed it, backed up by solid proof. First up, you've got his theory of special relativity. The main takeaway is pretty simple. The faster you blast through space, the slower time ticks for you compared to somebody standing still. Then you've got the other side of the coin from his theory of general relativity, gravity. The stronger the gravitational pull you're in, like near a black hole, the more time gets stretched out and slows down. And again, this isn't just theory. We see it working every day. Scientists have literally taken super precise atomic clocks, put them on jet planes, and flown them around the world. And guess what? They come back running just a tiny fraction of a second slower than the clocks left on the ground. But here's the one you use all the time. GPS. Your phone's navigation only works because the satellites orbiting Earth are constantly correcting for time dilation. Without those adjustments, your GPS location would be off by several kilometers every single day.
Okay, so we've established it. Traveling to the future? Totally possible. In fact, we're all doing it right now, just very, very slowly. But what about the big one? The one everyone really wants to know about. Can we go back? Well, this is where we leave behind proven science and run headfirst into some massive problems. So if you've ever looked into this, you've probably heard of wormholes. The idea is, in theory, you could create a shortcut through space-time. And if you could, say, keep one end of the wormhole stationary while you rocket the other end around near the speed of light, you could create a time difference. You might just be able to step through one end and pop out in the past. Sounds cool, right? But the gap between that idea on paper and in reality is, well, it's cosmic. So what's stopping us? Well, just a few little things. First off, we have never, ever seen one. They are completely hypothetical. Second, our math says that to keep a wormhole from just snapping shut instantly, you'd need something called negative energy, or exotic matter, which we're not even sure exists in the way we'd need it to. And finally, even if you solved all that, they'd probably be ridiculously unstable. So, for now, wormholes are staying firmly in the realm of theory. But you know, the problems with going back in time are way bigger than just building the right machine. It seems like the universe itself has some really strict, hard-coded rules, and going backward in time, that seems to break the most important ones. And the biggest, most fundamental rule of them all is something called causality. It's a fancy word for a super simple idea. Causes happen before effects. You drop a glass, then it shatters. You don't see the glass shatter and then watch it fly back into your hand. Traveling to the past would tear that logic apart. You could create paradoxes that would unravel the very fabric of reality.
This brings us to another huge concept, the arrow of time. There's this fundamental law of physics, the second law of thermodynamics, which basically says that things in the universe always tend to go from a state of order to a state of disorder, or from low entropy to high entropy. Just think about an egg. It starts off perfectly whole, right? That's low entropy, nice and orderly. Then, splat, it shatters into a mess. That's high entropy. And here's the absolute key. You will never see those shattered pieces magically fly back together into a whole egg. That one-way street from order to disorder is what gives time its forward direction. All right, so we've looked at the real, proven science of future travel, the massive theoretical problems of traveling to the past, and the fundamental rules of the universe. So where does that leave us? After all that, what's the final verdict on time travel? It's actually pretty straightforward. Traveling to the future? Yup, that gets a big green check mark. It is real, we have measured it, it is a scientific fact. But traveling to the past? That gets a big red X. It remains completely theoretical, totally unproven, and appears to be forbidden by the very principles that hold our universe together.
So, based on everything we know right now, the past seems locked. But that leads to the ultimate question, doesn't it? The one that keeps scientists dreaming. What if we discover something new, a new law of physics we can't even imagine today, that just flips this whole thing on its head? Because that's the beautiful thing about science, right? It's always evolving. So while the verdict for now seems pretty clear, the final chapter on time travel has definitely not been written yet.